Okay, I almost made it. Almost finished this example. Let's go right back through it. So again, a real estate ad suggests that 64% of homes have garages, 21% of homes have swimming pools, 17% have both. What's the probability that a randomly selected home for sale has a pool or a garage? Probability of pool or garage. Okay. As I kind of left off in the last video, again, this is an OR statement. There is overlap, so we have to remove the double counting. I would recommend writing out the rule. I want the probability of selecting someone or a listing that has a pool plus the probability that the listing has a garage. And then I'm going to have to subtract out the double counting I did. I'm going to have to subtract out the probability, probability that the listing has a pool and a garage. Kind of remove that double counting. Well, the probability that there is a pool, they said 21% of listings have a pool. The probability that the listing has a garage, there's 64% of homes say they have a garage. And subtracting the double counting, it says that 17% of listings have both features, so minus 0.17. For a grand total of 0.68. That is the percentage, or 68% would be the percentage of listings that have a pool or a garage. Okay, and then just like the last one, how about the probability of selecting a listing that has neither of them, a pool nor a garage? Probability of pool nor garage would be not pool or garage. And just like we did with the prior example, easiest way to do this is recognize like, well, this is a complement, so 1 minus the probability of this event, the probability of getting a pool or a garage. So we already calculated that probability at 68%, so that would be 0.32, or 32% of homes have neither a pool or a garage, at least according to this real estate listing. Okay, let's go on to the next page. Now, we're working towards the multiplication rule. This is not it. We first need to talk about conditional probability. Very important topic here. This is it. This is how we write it out. Okay. It's actually not that bad, and I'm going to kind of come off to the side and do some examples to kind of help elaborate on this a little more. Essentially what happens is, the way this is read is you're looking for the probability of event B given that event A happened. All right. So remember, back to probability, one of the easiest ways is probably to think of your sample space. Okay, what are all the possible outcomes that can occur? How many ways can we achieve our success? Divide that by the number of outcomes and you got your probability. All that's happening here is they're saying, well, this event took place. What that might do is that might shrink down my sample space. So basically, we kind of need to just live in the world where, like, okay, well, that happened. Now that that happened, now what's the probability of getting B based on the fact that A happened? Okay, we'll come off to the side and do some examples. Now, let me just look at this formula real quick. I do not use this formula. I would not recommend, well, let me not say that. There will be times when maybe this is useful, but I would say that it's best to use reasoning. Right? It's best to kind of just think about it this way, that, well, now my sample space is changed. According to that new sample space, what's the probability? The formula is that the probability of B given A is found by taking the probability of A and B over the probability of A. Okay, that's not very clear, but you could see it in an event diagram a little better. If we've got event A and event B and we're assuming some overlap, here's what I'm looking for. I'm looking for the probability of getting in bubble B given that I am in bubble A. In other words, we're saying event A happened. Event A took place. So knowing that event A took place, what's the probability that I can land in bubble B still? Right there. That's the only way to achieve a success of landing in this B bubble. So remember, probability is what you want over what's possible, or the number of ways to succeed over the total possible outcomes. Well, what I want is to be in this bubble. That right there is this, right? And the total possible outcomes would be, well, I'm in bubble A. I have to be, right? Bubble A happened, so I'm in bubble A. So the probability of B given A is simply the probability of landing here divided by the probability of being in the A bubble. Before we do some of these examples, I want to come off to the side, and this might take the rest of the video, I don't know, but a great way to think about these is to think about a bag of marbles. Okay, so I'm just going to make one up. So let's say, suppose we have a bag of marbles. So let's say I've got, how about 8 red marbles, numbered 1 through 8. I've got maybe, let's say, 5 blue marbles, blue, numbered 1 through 5, and let's just say, how about 3 green marbles, numbered 1 through 3. So what I'm looking at is I've got, 8 red marbles. Let's do it this way. These are all my marbles. 1, 2, 3, 4, 5, 6, 7, 8. Those are my 8 red marbles. I've got 5 blue ones. And then I've got 3 green ones. But there's 2 things happening. Not only am I pulling out a marble and looking at its color, I can also talk about the number that appears on the marble. So let me just throw out some conditional probability. And by the way, this is just a great test type scenario. You know what I mean? Because everyone can kind of wrap their head around this marbles in a bag idea. Just to keep note, in total there are 16 marbles. So what if I said, what's the probability of getting a, a red marble given that there's an odd number on it? Okay, so if I just wanted the probability of a red marble, let's just come up here and suppose I just want, what's the probability of a red marble? Well, there's 16 marbles total. How many of them are red, right? How many ways to achieve success? There's 8 of them that are red, so it's 50-50. It's 1/2 chance to get a red marble out of here. But what about the probability of getting a red if I tell you that I've picked an odd one? In other words, I reach in the bag, I pull out a marble, and I look at the number and I'm going, oh, this is an odd number. I'm no longer talking about all 16 numbers. I'm only talking about the odd ones. In other words, this is my new sample space. I'm not talking about every number. I'm only talking about those odd numbers because I'm telling you that I pulled out an odd. And knowing that I pulled out an odd, now what is the probability of getting a red one? Okay. Well, how many outcomes are there? How many odd numbers might there be that I could choose from? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 odd marbles there. How many of those were red? Again, I'm looking for the number of successes out of that batch of odd numbers. How many are red? 1, 2, 3, 4. So 4 out of 9 is the probability of getting a red marble given that I'm holding an odd one. Let's try one more. What's the probability of, let's see here. How about getting an even number on my marble given that I'm holding a blue marble? If I just wanted the probability of even, so just even, not the blue part, then it would be, well, count up all the even numbers. 1, 2, 3, 4, 5, 6, 7 out of 16. 7 out of 16 chance to get an even marble. But this is a little different. This is saying, okay, I reached in the bucket, I pulled out a marble, and it's blue. The marble is blue. So in other words, I don't care about the red marbles. I don't care about the green marbles. My sample space has shrunk down to this. I'm only looking at the blue marbles. I know the one you're holding is blue. Of those blue marbles, and there's 5 possible outcomes, how many of them have an even number tied to them? Just 1, 2. So the probability of selecting an even, given that there's a blue marble in your hand, is 2/5. Again, the idea with these conditional probabilities is they're telling you this event happened. Based on that event happening, the fact that you're holding a blue marble in your hand, now calculate the probability of getting an even number. Okay, so what it does, this conditional probability shrinks down our sample space. Let's see if I could do this page. Just let's skip this for a second. Let's talk about a deck of cards. Suppose we draw a single card at random from a deck of cards, and flip back a page if you need help remembering what the deck of cards looks like. But let's start here. They say, what's the probability of getting a heart? Well, if you remember, there's 52 cards in total in the deck. 13 of them are hearts, so 13 out of 52, which we can reduce to a fourth. What's the probability of getting a red card? Well, again, there's 52 cards total. If you look back to the deck of cards, half the deck is red. 26 of them are red. So you would have a 50-50 chance of getting a red card. The probability of getting a king, again, out of 52 cards, there are only 4 kings in the deck. So that would be a 1 out of 13 chance. Once again, I'm flying through these. Please pause and you do them and check your answers, okay? I'm racing the clock down here in the bottom corner. Now let's look at some conditional probabilities. What's the probability of getting a heart given that you're holding a red card in your hand? All right, so let's think about this for a second. I'm holding a red card in my hand. That happened. How many red cards are there in the deck? We said that there were 26 red cards. So again, now my sample space has shrunk down. I'm no longer talking about all 52 cards. I'm only talking about the red ones. Those are the ones I'm interested in, only the red ones. So there's 52 of those. Of those red ones, the 26 that are red, 13 of them are hearts, which would reduce to a half. And some people might look at this and think, well, this is just backwards. They've got to be the same. Not necessarily. What's the probability of getting a red card given that you're holding a heart? That's a little silly. If you're holding a heart in your hand, first of all, your sample space is shrunk down to only 13 cards because there's only 13 possible hearts. What's the probability that it's red? Of those 13 hearts, how many are red? All of them are. They're all red. So this one's a little bit silly. There's a 100% chance that when you, if you've plucked out a heart, that it's going to be red. Okay, let's try this last one. What's the probability of getting a king given that you've drawn a heart? So again, I pulled a card and I just tell you, well, it's a heart. So knowing that it's a heart, what's the probability that I'm holding a king? Well, there's 13 hearts available. And if you look back at the diagram or you know your cards, there's only 1 king of hearts. So there's only 1 chance to get a king if I'm holding a heart in my hand. So 1 out of 13 would be it. Okay. Time to quit. This one I'm 99% certain is in the what am I trying to say? Is embedded in your homework, in the description of your homework. So I'm not going to do this one on video. I'll write it out so you'll have it on the printed notes when I submit them to Canvas, but otherwise I'm going to jump to the next page, okay, for the next video, because I believe this one is explained. But again, look online. I'll have filled this one out on the notes for you. Okay, see you in a bit.